Good morning all. This is Kavipriya, Assistant Professor EC Department. I am going to discuss about the topic JFET, Junction Field Effect Transistor, construction, working principle, characteristics and applications of JFET. And this is my flow of presentation. I am going to give an introduction about the JFET and about the construction, working principle and finally about the characteristics of a JFET. So we all know JFET is a type of a transistor. It is a three-terminal device. It has a three terminals, namely drain, source and gate. It is a voltage control device. BJT is a current control device, whereas JFET is a voltage control device. The applied voltage across a gate terminal controls a current flow between a source and the drain terminal. As like BJT, JFET can also be used as an amplifier, it can be used as a switch and it can be used as a voltage control resistor. And this is the symbol for the JFET. It has a three terminals, drain, gate and source, and it is available in the two configuration. One is a P channel, another one is a N channel. In P channel, current flow will be away from the gate terminal. In case of N channel, it will be towards the gate terminal. And next is the features of a JFET. It has a three terminal gate, drain and source. It is a voltage control device. The applied gate voltage controls the current flow between a drain and the source. It is a unipolar device. The current flow in case of JFET is due to the majority charge carriers. In case of N type, it is due to the electron, and in case of the P type, it is due to the holes. JFET generally has a very low power dissipation, hence it is widely used in the most of the applications. And this is the construction for JFET. In case of JFET, there are two types of configurations available. One is a N type and another one is a P type. N channel JFET and P channel JFET. In case of the N channel, the channel is made up of N type material and will be having a two PN junctions and gate terminal will be taken from the P-type material. In case of P-channel JFET, the channel is made up of P-type material, P-type semiconductor material, and two PN junctions will be there, and the gate terminal will be taken out from the N-type semiconductor material. And next is a working of a JFET. Here we will be having a N-type channel and P-type channel, and the applied gate voltage will be controlling the current flow between the drain and source. Two PN junctions will be available on the either side of the channel, and thereby it will be creating a depletion region. And we'll be applying only the reverse bias voltage over here, and that too applied across the gate terminal. The applied reverse bias voltage will be widening the depletion layer, and thereby it will be narrowing the channel. Once the channel is being narrowed, it reduces the current flow between the source and the drain. The applied gate voltage controls the current flow, hence we call this JFET as a voltage control device. Here in this diagram it is shown the complete working of a JFET. The gate voltage, reverse bias voltage is applied across a gate terminal, and the current flow will be occurs between the drain and the source, which is nothing but ID. ID is a drain current. The voltage that is available across the VGS, gate and drain terminal, is a VGS, and the current flows between the drain and the source terminal is a ID. So when we apply the reverse bias voltage, the depletion region will be widened, and thereby narrowing the channel available across the P and N type material. Once the channel is get narrowed, the current flow between the drain and source terminal will get reduced. The current source is indicated as a ID. So ID is gradually reduced. And this is a diagram for N channel JFET. And this is a diagram for P channel JFET. Here the channel will be a p-type material and gate terminal will be taken out from the n-type material, and reverse bias voltage will be applied across the gate terminal. The applied reverse bias voltage widen the depletion region and thereby reducing the channel width and thereby reducing the current flow between the drain and the source terminal. And we have two characteristics for JFET. One is a output or drain characteristics and other one is a transfer characteristics. So first one is a drain or output characteristics, which is a graph drawn between a drain source voltage VDS and the drain current ID, keeping the VGS constant. VGS is nothing but it is a voltage that is available across a gate and the source. We have four terminologies involved in this. First one is a saturation, second one is a ohmic, third one is a pinched off, and fourth one is a breakdown. In saturation region, the VDS value will be very low and the current ID is a constant. The current ID is controlled by the voltage that is available across a gate source terminal, which is nothing but VGS. In case of the ohmic region, the VDS will be gradually increasing and thereby ID will be increases. In pinch off region, even by increasing the VDS, the channel will get narrow and the drain current at one point will becomes independent of the VDS. So even though if we increase this VDS, ID will remains constant. In breakdown region, if we increase the VDS further, the channel that is available will get completely breakdown and the current will be flowing in an uncontrolled manner. And this is the transfer characteristics. Transfer characteristics is a graph drawn between the drain source voltage and the VGS and the ID. It is a gate source voltage and the ID, keeping the drain source voltage constant. The transfer characteristics is exactly opposite to that of the drain characteristics. So in the graph, in the same graph, both the output characteristics and the transfer characteristics are indicated. In output characteristics, it is a graph drawn between the VDS and ID, keeping the VGS constant. Whereas in case of transfer characteristics, it is a graph drawn between the VGS and ID, keeping the VDS constant. So it is exactly opposite to that of the drain characteristics. Advantages of JFET are, it is very low, it consumes only very less power, and it is more energy efficient, it is very stable, it produces a very high input impedance, and it is very simple to use. And drawbacks are, it is a unipolar device. Current flow is due to the majority charge carriers. And there is a chance for leakage of current between the gate and source terminal. The availability of JFET is very less, hence to find the specific JFET based on the application is quite challenging. And the gain of this JFET is very low when compared to other transistors, hence it is not suitable for high gain application. It is expensive, hence it increases the overall cost of the electronic devices. Applications are, it is used in the low noise and high impedance amplifier, it is used in the switching circuit, it is used in the sampling process, sample and hold circuit, it is used in the voltage regulator and oscillators. So FET is a voltage control device, and one of the statement about FET is that it has a high input impedance. In N-channel FET, the direction of current flow is from drain to source. That's all about the topic JFET, and we have discussed about the construction, working, and also finally about the characteristics of the JFET. Thank you.